Alright, John, sorry about that. My computer actually shut off, so that's fine because we're just going to keep on going with this stuff. I drew a table up for us where we have a list of 4 different functions and we just have to find the amplitude, the frequency, and the period. So we're just going to do that, and I have one more thing left to tell you and then you're going to be done for today. So the amplitude range, what I mean by saying amplitude range, obviously we know that the amplitude is 3, but what I mean by range is the amplitude of 3 means that the range goes between -3 and +3. So y is greater than -3 and less than +3, and that's what I mean by that. The frequency is just the b, which you see in the equation, so the b, or the frequency, is 2, meaning that I'm going to see 2 full curves between 0 and 2 pi. Okay? And then the last one is the period, and that's the one that we have the equation for, 2 pi over b. That's going to tell us how long does it take to see one full curve. So the period in this case is 2 pi over 2, which is just pi. So that's not that bad. Okay, this one, the amplitude is 2, so the amplitude range goes between -2 and +2. And it's always less than or greater than or equal to, because the function actually does hit the -2 and it does hit the +2. Okay, so make sure that you have those symbols written out correctly. The frequency is just 1, meaning I'm only going to see one curve between 0 and 2 pi. And then 2 pi divided by 1 tells me that my period is 2 pi. So how long does it take for me to see one curve? 2 pi radians. Okay, the amplitude for this one, my amplitude is 1, so I'm going to go, my minimum is going to be -1 and my maximum will be a +1. My frequency is 1/2, which is kind of different. We haven't seen that as much, meaning between 0 and 2 pi I'm only going to see 1/2 of that sine curve, so just the hill part. I'm not going to see the valley. So when I do 2 pi divided by 1/2, it's going to get a little bit complicated because now I have to multiply by the reciprocal. So I'm going to multiply the top and bottom by 2 over 1. Everything down here cancels out. 2 pi times 2, that's 4 pi. So how long does it take for me to see one curve? It's going to take 4 pi radians. And then the last one, my range is between -1/2 and +1/2. There was a negative right there. My frequency, or how many curves am I going to see between 0 and 2 pi? My frequency is 1. And same thing as up here, my period is going to be 2 pi. Okay? Alright, the only other thing that I have for you today is this thing that we have about Miss Tompkins wants us to graph, and I'm going to pull up my graphing calculator to do this. Y is equal to sine of x and y is equal to negative sine of x on the same set of axes so that we can compare them and look at how they're similar and look at how they're different. Okay, so let me grab my graphing calculator. Sorry, my computer shut down and everything turned off with it, so I had to kind of pull everything back up again. Okay, so let's go to y equals. Make sure I'm in radians first, and I'm not. Make sure I'm in radians, and I'm going to go to y equals. I'm going to type in sine of x for the first graph, and then negative sine of x for the second. And I think that I do have to go back and change my window. My x minimum is going to start at 0, go all the way out to 2 pi, just like before. My y minimum is going to be, well, we're graphing this, so our amplitude is between +1 and -1. So my y minimum is going to be -1, my y maximum is going to be +1. Now I'm going to graph both of those on the same set of axes. So that's just sine of x. and then this is negative sine of x. So what can we take a look at? What is the same and what's different? Well, for both of these, they actually have the same amplitude. The amplitude stays the same. And you can see that because amplitude just tells us how high and how low they go. Well, sine of x has a maximum of 1 and a minimum of negative 1. Negative sine of x also has a maximum of 1 and a minimum of negative 1. So the amplitude is the same because the amplitude is the absolute value of whatever number's out there. So for sine of x, the absolute value of 1 is just 1. And for negative sine of x, the absolute value of negative 1 is also 1. So you can see how the amplitude is the same. That's the A. The B, or the frequency, is the same as well. The frequency tells us how many curves do I see between 0 and 2 pi. Well, I see one curve on both of those, so the frequency is the same. And the period is also the same, because how long does it take for me to see one full curve? It takes me 2 pi. So what's different about these two graphs? What changes when I put that negative out front? Well, you can see this one goes up the hill first and then down the valley. This one, negative sine of x, goes down the valley first and then up. Okay? So it looks like they are the exact same graph, except for it flips over the x-axis. So what Miss Tompkins has written out is that y is equal negative sine of x is a reflection of y is equal to sine of x. So it's a reflection over the x-axis. Okay? And that would be the exact same case if you did the same thing to the cosine curve. Okay? Alrighty, so besides that, now what you can do is you are now able to complete homework number 77. Alright, and go through that stuff, and if you have any questions, then just call me or text me or whatever, and I will hopefully see you tomorrow. Okay? Yeah, no, I'll talk to you tomorrow. Okay, see you later.